Hi, in this session, we're going to discuss about our important question asked in C interviews related to const. Const is a qualifier. When applied to an object, the contents of that object cannot be modified. But here the question is, in which memory segment are const variables stored in a C program? The straightforward answer for that is, const variables are not tied to a single fixed memory region. The placement depends on how and where they are declared. I can apply const for the local object, I can apply const for a global object, and I can also apply const for a static object. We'll try to understand each of this in detail. Let's start with const applied to a local variable. Now this is a local object which is a non-const. This generally goes into stack memory. Now, if I apply const for a local variable, where will it be stored? This will be stored in stack segment. Now, how do we verify this? To verify this, I'm going to display the address of X and the address of Y, right? And since I'm basically using the printf statement, I need to also include the header file stdio.h. Let me try to compile this program and run this. And you can just observe, if you look at these addresses, it is B70, B74. It's just like adjacent to that. Okay. Now, the next question is stack a read-only memory or read-write memory? It is a read-write memory. So can I modify the value of Y? As we have discussed, const cannot be modified directly, but it can be modified indirectly. Like I'll try to use a pointer. And remember, here, directly writing this is not allowed because Y is a constant object and it will be expecting that we require a pointer to const to hold the address. But what I'll try to do it is, I will try to typecast it to a integer pointer, which removes the constness. Now, I would like to modify the value of Y through the pointer indirectly. I'll try to modify the value of Y indirectly. It can be any value now. After this, I'd like to observe the value of Y. Is it modified or not? See, I'm not modifying directly through Y. Modifying directly through Y, the compiler will identify and then it'll tell you that you're not supposed to modify. Whereas I'm indirectly modifying it. Now, I would like to see the value of Y. Right? If you want, you can also see the value of Y before. Here, in this particular place, the value of Y will be 5. But we need to observe what is the value of Y here. Is it modified or not? Let me try to compile this and observe this. Y was 5 here. Y is changed to 12. So from this, we could understand that a local constant object can be modified indirectly. But is it a good way to do that? The answer is no. We are not supposed to do this typecasting and removing the constant and then modify it. It can lead to trouble, especially in cases where the compiler would have optimized it. And then in such situations, instead of fetching the value of Y from the memory, it looks at it like Y is const. I will try to write the value to print 5 rather than fetch the value from the memory. In such cases, you might not get the updated value, right? Right. So I hope this is clear with respect to the local const objects. Now, the next thing what we'll try to do it is we'll try to take up a global const. I will just try to write A. I can take up any value and I'll try to take up B, which is again a global variable. To reduce the complexity, I'm trying to remove the other statement which are irrelevant. And I'd like to first observe in which memory segment are this A and B stored, right? Now this A is stored in a segment called as data segment. Okay, it's called data segment. What about B? Is it also stored in the same data segment as where A is stored? The answer is no. It is basically stored in RO data segment. We call it as RO data, which is also called as read-only data segment. Okay, how do I verify this? I can show you this by showing you the symbol table entries. First, let me try to compile this. I just want to compile, generate the object file, and then stop. I don't want to do the linking. After that, if you want to have a look at the symbol table entries, I can take the help of nm and I can pass on the object file. If we observe here, the object A is in data segment and the object B is in R segment, which is read-only data segment. Okay, right. The other way to understand that is if you can basically generate the assembly file. And then if I look into this assembly file, you could observe that it is in dot data segment, the object A and the value is 5. And here the object B is basically in section RO data. This we can observe by looking at the assembly code. Now the next question is, can I modify this global const object? Okay, yeah, before I could demonstrate modification, I would like to show you the addresses of this A and B. Are they adjacent or are they far off? So I'm just trying to print the addresses, compile, generate the executable file, and then run this. If you just observe, this is at address 9010, this is at 7004. It means they're not adjacent, they're a little bit far off, two different segments. Fine. Okay, this is to prove that there are two different segments. Okay, one is the read-write data segment, which is called as data, and the other one is read-only data segment. Now let us try to modify the value of B indirectly. The same thing what we did for local variable. I'll try to remove the constants, address of B, and I would like to write this valued B or valued PTR equal to some value 8. I'd like to print this B equal to %D. I'd like to print this. The same thing I would like to do it here. Okay, right. Now I'd like to compile this. While compilation, you can just observe there is no warnings, no errors. Now let me try to run this program. When I try to run this program, first it is basically giving the value as 5, and the next statement it is basically giving me a segmentation fault because you're trying to modify the contents of read-only segment. If you want to understand which statement exactly gave you this problem, then what we can do it is we can debug this program. If you want to debug this program step by step, I can use this option -G. Then I can start my debugger. Okay. Now GDB is a program for debugging. And then first we'll set a breakpoint. I'll start the execution. And I'll say next. To execute next statement, it's going to print the addresses. The addresses are far off. Then this is going to print the value. Perfect, fine, no problem. This statement, like, okay, this particular statement has captured the address of B. So if you want, I can use print address of B. I can also say print PTR. You can just see PTR is actually holding the address of B. Now, if I say next, and this particular statement, line number 15, if you just observe this, this statement gave me a segmentation fault. The reason, you tried to modify a segment where you only had read only. Clear? So global constants objects are basically stored in read only segment. Any attempt to modify it directly will be caught by the compiler. Any attempt to modify indirectly will be caught at the runtime. Now the next question is, what about local variables which are static? Like I have a local variable, it is const, but along with const, it is static. Now, all local static variables will also be stored in data segment, but if it is const static, it will be stored in read-only data segment. Right? Now, I'd like to also print the address of X. You will observe that it is near about to B. Okay, it is near about to B. Right? And on the same lines, I would like to store, okay, capture this address of X, try to modify this and try to print this. Clear? Right. Now, first, I'll try to compile this. And while compilation, I'd like to have a look at the symbol table entries. Now the question is, are the local static variables, are they captured? And the answer is yes, it is captured. It is in read-only segment. But remember, these are global variables. That is why you will see this in uppercase. There's a local variable. Plus there's a name mangling, which happens for the local static variables. Right? Now there was no compilation error as such. Now I'd like to generate the executable file. I'd like to run this. Observe the address of B is B004 and this is B034. But observe it is B, okay, 00. The only difference is 30 bytes here, but this was in a different, like completely in the D0. But again, you can see the segmentation fault here. So from this, what we basically learned is a local const variables will be stored in a stack segment. Stack segment is a read-write segment, which we directly try to modify, will be caught by the compiler. If we indirectly try to modify, we can modify that. Whereas a local const variable, which is static, or a global, okay, const variables, they will be stored in read-only data segments, and any attempt to modify directly will be caught by the compiler. Indirectly, if you try to modify, it will be caught at the runtime. Right? I hope the concept is clear. Thank you.